So when we talk about to find the minimum value of the MSE value, okay, we differentiate. So we let it differentiate equals to 0 to find the best A and B, which is A star, B star, which is the best model. However, practically, we usually we don't do this. Here's the reason why. Let's take a look at this view graph. Let's write A right here, B right here. It's a 3D figure, okay? That is MSE value, okay? So we have n from 1 to 20. So we have a lot of data points right here. So if I don't want to do any computation of differentiation, 就是我不想要做任何微分的话 what is the best strategy for you to find the best A star and B star? So the question is that if you don't want to do the differentiation, okay, because you have a lot of features. So basically, if you have multiple features, so your linear regression function will like this. Okay, general form, you have n plus 1 parameters, just like A star and B star. Okay, theta 0, theta 1, theta 2 until theta n to represent your model minus y. Okay, that is your MSE, right? Okay, and for example, you have 20 data points. So you need 20 data points to calculate the minimum value of MSE. Let's simplify it, okay? B theta 0, right? A, that is theta 1. For example, if we have only two parameters, okay, we use A and B, not theta 0 and theta 1. The MSE value is right here, okay? So if you input those 20 data points in your MSE function, and you can make a mesh 就是一个网 you can make a mesh. So any pair of A and B will represent a model, right? And we show the MSE value of this model at z axis, 就是 z 轴就往上跑 z axis. So as we can see that it is a mesh, and you can find the minimum, the lowest point on this mesh. Right? So there's always a best A star, B star, or theta 1 star. Okay, if you use this notation, theta 0 star. Right here, which represent at least point as this combination of A star and B star, or theta 0 star, theta 1 star. There is the best model which you measure by MSE value. So there is always a mesh right here. So one of the best way to find this optimized value looks like this. We randomly pick up a A and B value at time 0. So it might be right here, A0, B0. But apparently, it is not the optimized value of A and B, right? So basically, we observe, of course, using mathematical tools. And there is a direction from perspective A. 我们从 A 的角度看 it should be like this direction. If you go to this direction from the perspective A, you can get smaller MSE value, 对吧？所以你往那个方向去，对 A 啊 ，A 是这一种，你只要往那边去，你 MSE 就会变小。From the perspective of B, if you go to this direction, the green direction, you can always find the small value of MSE if you go to this direction. So at time t equals 1, you go to the direction which makes your MSE smaller. So A0 goes to A1, B0 goes to B1. But the direction which on the surface, 就是在这个平面上 How can we get this direction? By using partial differentiation, 也就是所谓的偏微分。It is a mesh, it is a function, it is a curve. If you do partial differentiation, 偏微分 on a specific direction, 就是在一个特别的轴上 then you can know which direction is a tangent line. Tangent line 就是切线 is the tangent line. The direction of tangent line is the direction which you should go because in that direction you get smaller MSE value. So and so on and so forth. So in this way, at time t0, you start from a random number, and at time t1, you go to this way, to this value, and t2 go to this value, and so on and so forth, so on and so forth. If you have enough time, and then you approach, 你会逼近 the optimized point. But at certain moment, okay, you have to look it very carefully. For example, the blue one is the optimized one, okay, maybe it's right here. That is the optimized one. So the black point is like here. You go to this direction to this point, you go to this direction for this point, you go to this direction for this point. And for each round, 就是在每一轮, you have a strike. Strike 就是跨步的意思. Okay, 跨步的意思. You have a strike. If your strike is a little bit bigger, you may accidentally go to the other side. 就是如果你的跨步设定不好的话，你会不小心的跨太大步，然后略过 and you pass the optimized point to the other side. However, when you do the partial differentiation in next round, 你在下一轮做偏微分的时候，你会知道你走过头了。You know you already passed the optimized point. So at that point, you will go back to the other direction, try to approach the optimized point. Okay, so if you draw this figure in 2D, it may look like this. Okay, here is the optimized point. Your trajectory 就是路径. Your trajectory may look like this. And you go to the other side, come back, go to that is the approach we use in machine learning, in certain machine learning algorithm. We don't calculate A star or B star or theta star directly. We just simply random select a value for A and B or for theta. And we do partial differentiation to see which direction we should go to in next round. And we approach step by step. And we'll try to approach the optimized point after several rounds. That is the way we do. Okay. Before I continue, I'd like to go to a very beautiful graph. It's right here. This approach is what we call gradient descent. Okay, here's the reference. Okay, here's the reference. This graph is selected as one of the most beautiful science view graph in 2018. It described in a surface, a very complex surface. Why this surface is much complex than what I showed you before? Because it has multiple variables, x1, x2, x3, xn. Has multiple variables. Okay, so here, the black point, that is the random select starting point when you do gradient descent. So it will follow the direction of the current tangent line, 就是现在的切线啊。When you do partial differentiation, 就是你就做偏微分的时候的那个切线 ，and try to figure out where is the lowest point of the MSE. Okay, because we have multiple variables, so the MSE surface is not that smooth. So that is MSE, right? In here, okay, we have theta. And here, that point is theta star. And at that point, the theta star is the best parameter for that model.